Alright, welcome to Tactic Academy, where I'll be looking at electron configuration. So you guys master this trick. It's a nice trick than any other trick you know. Okay, so without even wasting our time, shall we get started? Okay, so let me take you just back. We remember something. So if we can talk of our orbitals, all right? Orbitals, that's where electrons are found, right? So we had S, P, D, F, G, but for our case, we only end at what? At F. It's enough for us. F, S, P, D. All right. So what we do is now, let me say this is S, all right? So the orbital will look like this, all right? Where it's just a single orbital, and it will only accommodate the maximum of what? 2 electrons. What about p orbital? So this p orbital, all right, this one has what? 3 orbital, all right, in it. So these 3 orbitals, they will accommodate at least the maximum of what? 6 electrons, all right. So that's about p orbitals. Let's go to now d orbital, spd orbital, all right. So d orbital will have what? 5 orbitals in it, and these 5 orbitals, they will accommodate at least the maximum of what? Of the maximum of what? The maximum of what? Of 10 electrons, all right. So 10 electrons will be there, all right. So that's the maximum number of electrons that can be what? Accommodated by d electrons. So they are 10. 1, 2, 3, 4, 5. They should be 10. Then F. So for F orbital as well, so F orbital will look like this. So these are the orbitals I'm writing here. So F orbitals will have what? We add 4, so these ones will be 14, all right. So what we do is 1, 2, 3, 4, 5, all right. So it's, so they will have 14, meaning they are 7, right? 1, 2, 3, 4, 5, 6, 7, like that. Okay, so normally at our case, we don't even tackle what? F orbitals, believe me on this one. So what we do is we put the electrons like that, all right. So it can accommodate the maximum of 14 electrons, all right. So that's about what? F orbital, all right. So we'll concentrate much on SPD. So these guys, they have, so know that this will have at least the maximum of 2 power. That's the number of electrons which are there. Then this one will have at least the maximum of what? 6 electrons. So this one will have at least the maximum of what? 10 electrons. So these are the number we'll be putting to fully fill the orbitals when lighting electron configuration. So we are just representing orbitals with their what? Their number of electrons inside. So let's go to the trick. So what you do is you write, so there are 2 ways. So you have been using this trick to say you write 1s like that, then you come here, you write 2s, all right. Good, you write 2as, then 2p like that. Then again you write 2 what? 3s, all right. Then 3p like that, then 3d, all right. This is what you have been doing. 4s like that, 4p, all right, 4d, all right, then 5f to say, all right. So this is what you have been doing, and you have been writing these lines to actually trace these things, all right. Now we'll not do this, all right. So this one is confusing, but we'll just do something else, all right. Let's see the trick I'm talking about. Okay, so what we do is you say you arrange these orbitals, you arrange these orbitals. So you light SP, D, let me light F. By the way, I'm not supposed to light what? Capital letter. Okay, I'm supposed to light small letter, all right. So this is SPDF. So what you do is you can see S is number 1 there, then P is number 2, D is number 3, then F is number 4, all right. So what we do from here, we do what? We say, since this is, I'll be going twice to my left, so I'll do this, I go twice. Again on the second round, I'll come like this, all right. at twice again. I start at D, come like this twice again at F, twice like that. Okay, so what I'll do is I'll start at S, I'll go this side left to my left twice. So I'll name S as what? I'll put S as what? S twice. I've gone this side twice, right? Again I come at P, I light S, I mean PS. So I'll say PS like that. Okay, so after lighting this again I come at D, I come this side twice, so it will be now D what? PS again, D P, all right, D P S like that. Okay, so DPS twice. Then again I can come F DPS, so I'll say F, all right, F, so you say F D P S like that. Again F D P S. So this is the maximum we can have, guys. So it's okay, you can continue, but this is the end. All right, what you do is now you would start S. This is the first S that I have here, right? So this is the first S that I have here. This is the second S that I have here. This is the what? The third S that I have. This is the fourth S that I have here. This is the what? Fifth S that I have. This is the sixth S that I have. This is the seventh S. This is the what? 8S. All right. So what I'll do is for P it start at 2, right? So P start at 2. So I'll start 2P, here 3P, all right, here 4P, here 5P, here 6P, all right, here 7P, all right. Then I come now on D orbital. D start at 3, so I'll write 3D, all right. So I light 3D like that, so I'll say 3D, all right, 4D, because it continues like that, 4D. Then what is, do I have another D? Is 5D there. All right, so I'm done with it. Let me go to F now. All right, so if I go to F, all right, so if I go to F is the what? Is number 4. So the first F for D, I've missed one thing here. All right, for D, okay, so my D start at 3 here. All right, so my D is 3 there. Okay, since that's the first 3 I can see there. Okay, so for D, that's the first S I can see. So the next thing, the next 3 that I have, I mean D that I have, is now 4D. All right, then this is 5D. Okay, then this is what? 6D. I'm done with the D's. All right, so now I go to F. So the F's that I have what? I have how many F? So the F that I have this one here, which is now number 4. So I'll say 4F. Then do I have another F? I'll say 5F like that. So I'm done with this, guys. So this is a trick. You just have to not say, you just go twice on your left on each stage going to the right, now coming back to the left twice. All right, so what I'll do now is I'll do what I'll do, I'll just now put the orbitals now. Okay, all right, so what I'll be doing is I'll say S orbitals can accommodate what? S orbitals can accommodate what? 2 electrons. S again 2 electrons, P 6 electrons, S 2 electrons, P 6 electrons, S 2 electrons, D 10 electrons, P 6 electrons, S 2 electrons. All right, then D 10 electrons, P 6 electrons, S 2 electrons, F 14 electrons. All right, so D 10 electrons, P 6 electrons, S 2 electrons, F 14 electrons, D 10 electrons, P 6 electrons, S 2 electrons. So this is the pattern that I'll be using. Now I'll just choose, look at the proton number, for example for helium. All right, examples. All right, so helium or just hydrogen. All right, hydrogen has a proton number of what? 1. So I'll just go get there. All right, I'll just go get there and what, get that one. So that will be just one what, 1s, like that. All right, so 1s with what, just 1 electron. All right, so what if I give you for helium like that? So helium, it has 2. What I'll do is this, so this is for hydrogen, by the way. So helium will be just what, helium will just have the same one what, 1 electron, 1s. Now it is now filled with 2 electrons because the number is 2. The proton number of helium is 2. Let me cite another compound. Let me say carbon. All right, so carbon has what, has 6 number of electrons as proton number. All right, so what I'll do is, since carbon has 6 electrons, I'll count from here. I'll just do what, I'll just say, in your case, just end somewhere 5p. A lot of elements that they will give you, they won't list that. So what I'll do is, I'll write what I have 6. So I'll select this guy, all right, then this guy will have 4. So what I'll do is, I'll write first 1s with 2 electrons, because I know it will be filled is more than 2 electrons. So I'll go now on 2s what, again 2. I have remained with what, this is adding up to what, 4, right, these 2. So it's adding up 4. So what I'll do is, now I'll bring now this p orbital. So I'll write 2p. What, how many have I remained with from 6? So I've reused the 4 already, so this will be 2. All right, so I end there. So this is the electron configuration for what, for carbon. Then again, I can cite another compound. Let me say fluorine. Okay, or just the oxygen. Yes, so we know oxygen, it has a proton number of what, 8. So the electron configuration what, will just pick 8. So the first s will accommodate 2 fully, then the second s will accommodate again 2, making what, 4. Then we have remained with what, 4. So we'll go now to 2p, like that. Okay, since this 2p has what, this 2p now has remained with what, we have used the 4, remaining with what, 4. So we just put 4 there. You get the point. So very easy. Again, you come on this reference. Let's get for neon. All right, so neon has a proton number of what, 10. Okay, so since it has a proton number of 10, so the first 1s will accommodate 2 electrons, the second 2s will accommodate what, 2 electrons, then the second 2p will accommodate what, we have 10, so I've used 4, so it will be 6 there, right? So meaning that p orbital will be filled with electrons, in that there are 6 of them. All right, but for this case, under oxygen, the p orbitals had only 4 electrons, and that was worrying it. Okay, so it wasn't comfortable. It is not comfortable, this behavior. Okay, because electrons need to be paired. They are negative and positive when they are paired. Okay, so now that's how you can do it. You can let this configuration. Okay, hope that was very clear. So let me give you another examples, and also there is also exceptions. Okay, so some elements are exempted from being once is given such electron configuration, and we'll talk about them. Who are those electrons? Which are those electrons? All right, so now what we do is, let me give you for one element. Let me give you for calcium. So calcium, okay, so calcium has a proton number of what, 20. So since it has a proton number of 20, what I'll do is, I'll say the first one is what, 1s, okay, with 2 electrons. The second one is what, 2s with what, 2 electrons. The third one is what, 3s with what, 2 electrons. So far we have used how many? 6 electrons. By the way, this is the p. All right, I'm sorry for this. So I've really made a big mistake. So we are here now. Okay, so now we are writing now 2p with electrons 6. Now they are now 10. We have remained with what? 10. So what we do is we write 3s, which will get 2 exactly because they are still there. Then what we do again, we have used now how many? 12. So we write again what? 3p, as we can see there. All right, so this p will carry what? 6 electrons. So once they carry 6 electrons like that, then we can see that we have used how many? 2 plus 2, 4, 10, then 12, 18. Okay, we have remained with 2. So we just bring the same s. All right, this s will have now what? How many electrons? How many electrons will be there? Will be 2 electrons. All right, so this is the electron configuration one for what? For calcium. So it's very easy trick. Just master the way I approach, then write it somewhere even before answering, because they'll bring about 3 or 4 questions that just need you to calculate electron configuration. All right, so there are exceptions that I said earlier on to say there are other elements that are exempted from having required or expected electron configurations, such as scandium, chromium, copper. But I'll talk about copper and chromium because they like bringing about those two. All right, so what should I do then? Okay, so we are here now to simplify that for you. So what we do is copper. Okay, copper has a proton number of what? Copper has a proton number of what? What is the proton number of copper? Okay, I'm sure copper has a proton number of what? 29. All right, so since this is 29, we'll start now our electron configuration to say 1s from our reference there, guys. So 1s will have 2 electrons, then 2s will have what? Will have what? Will have let me use the other pen. Okay, we have started our electron configuration, guys. So we have 29 electrons. So what we do is now for copper, it will be first we write 1s, which will get 2 electrons because we still have a lot of electrons. Then we have what? We have what? We have 2s there with 2 electrons. Then we have 2p there with 6 electrons. We have 3s there with what? With the 2 electrons. We have 3p there with what? 6 electrons. We have 4s there with what? 2 electrons. All right, so adding up these, they are now giving us what? This is 4, 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 18, 18, 19, 20. So I need to remove what? There's this one. I need to remove these 2 there, which is there. So what should I do then? I know to say now they are 29, right? Like this. Okay, so we have 2 plus 2, 4. 4 plus 6. 4 plus 6 is what? It's 10. 10 plus 2 is 12. 12 plus 6 is what? 18. 18, then 19, 20. So this one will also be filled. So we have remained, these are now 20, right? So since they are now 20, what should we do? We continue. So we are now at 4s. So we are now going to 3D like that. So this 3D now, we have remained with 9. We'll put 9, but the maximum is 10 in its orbital. So I'll put what? 9 there. So have you seen now? This is the expected what? Expected configuration of what? Copper. Okay, so now this is the expected configuration of copper. So this is now it's not advisable to write it like this, because they tried by all means to put these electrons, I mean electron configuration for copper and also chromium, in an excited state. Excited state is a situation whereby another electron has just jumped to the other orbitals. All right, but that is what we call hybridization. But it is not really hybridization, because the energy levels might differ. For hybridization, energy levels should be the same. All right, so we can let in that way. So what we are going to do is now the correct one, you write it like this. All right, so we say 1s 2, 2s 2, 2p 6, 3s 2 there, then 3p 6, 4 s. So what is going to happen is that the s orbital will have the cross the s orbital will have 2 electrons in it. Then the d orbital now will have what? Need to have 10 of them, all right, but it has only 9 of them. So what is it going to do? So it's going to fill this 1 2. By the way, you start with the singular. By the way, 1 again there, 5 of them. Then I start now pairing 6 7 8 9. Have you seen that this orbital is vacant? So I mean is empty, is not paired. So what we are going to do is we'll borrow this one from 4s there, we'll remain with 1. So this electron will go there and what, feel that, because there are a lot, and the Gaussian will be affecting the configuration or the stability of an element. So what we are going to do is we will write 3, then d, so that electron will be shared, because this s orbital is comfortable even if it's sitting with 1 electron. So you get the point. So this will be now 10. So this is how you write electron configuration for what? For copper. It's happening also for chromium. It happens for chromium. So the other way you can write this electron configuration, you get the difference of hydrogen and what? Hydrogen and what? And argon. All right. So argon has what? The proton number of what? 18. Okay. Then this guy has the proton number of 2. So where there are what? 18 electrons, you can substitute and what? Put argon. So like this, these are giving you what? 18 electrons if you were to count. All right. So what you do in case of these electrons, you can even leave like this, or you can put what? You can put the same argon, which is just representing electron configuration of 18 protons or electrons. Then you write like this. Then you just bring what? You just bring 4s1 3d 10 like that. So you are done as the final electron configuration for what? For copper. Happens the same case with chromium. Should I show you even for chromium? So the exemption is just the same. They just undergo excited state of electron configuration. All right. So these guys, they just go electron configuration of excited state. The other electron jumps to the other orbital, so that's what we call excitation. When an electron jumps to another energy level, that's what we call excited. Okay, but it is when they are just within their normal thing, we call it ground state. Okay, so let me give you for chromium. Okay, chromium has a proton number of what? Chromium has a proton number of what? 24. All right. So this, since is 24, so what we are going to do is, we'll say the first one is what? 1s. All right. The second one was 2s. The third one is what? 2p. All right. The fourth one is what? 3s. All right. Then 3p. All right. Then 3d. I'm sure these are enough. Okay. So what we are going to do is, this one is 2 electrons, so this making 4. 6 there in p orbital making 10, so 2 there making 12, p there making what? 18. All right. So this is, since this is 18, we said there are 4. So what we do is 18 minus what? 24. What is 18 minus 24? All right. What is 18 minus 24? Okay. So I'm sure I've forgotten the other orbital, this orbital here. All right. So here after 3p there, I'm supposed to write this orbital. Okay. So after 3p is 4s. Okay. After 4s is what? 3d now. Okay. So see, let me see the electrons that I have. So I have what? I've used already 18. 18 minus 24. That will be 6, right? So I'll put what? 2 there. All right. Then here it will be 4. Okay. So now these guys, they are 10 orbitals like that. For what? For d orbital. I just want to show you something. This is d orbital of what? 3d there. This one we can see. So they should be 10 inside. But now we have what? We have only 4 electrons. So we'll pair them like that. So singular first, 1 2 4 like that, right? So it is lacking one thing here. So the d orbital is somehow respected for copper and also for chromium, so we make exemptions. So what we do is, now you say in the, this is now the, we can say this is the ground state configuration. So now excited, whereby an electron will jump to the other orbital, at least to fill this gap here. So it will borrow from s orbital. S orbital is comfortable even staying with one electron. So what is going to happen finally, the electron configuration for chromium, it will be now 1s 2, all right, 2s 2 there, 2p 6, 3s 2, 3p 6, 4s. Now this s will just get 1 and share to this guy who's lacking the space, I mean, who's lacking the electrons. So what will happen is that they will give it to be 5. You get, from 4 it has changed to 5. So this guy has donated 1 electron, so that this guy, at least it can stay like this with at least all the orbitals sealed. All right, so this is now the electron configuration for what, for chromium. This is what they advised now, but the expected was to be this. Because of this one, it undergo excited this state, and the ground state was the first one, then the excited state is the second one, whereby, so this is the ground one, this is the what, excited state. So excited state is the situation number, an electron has jumped from another energy level to another level. So that's the meaning here, from 3d 4s, it has dropped. In short, in this case, energy has what, has reduced from 4s to 4 energy level to 3 energy level. So meaning this electron has just lost some energy for it to drop. Okay, so the other way you can write it out, the same thing you get at this point is 18, right? So we said argon, it has that configuration from here to there. So if you are giving argon, you get this one, it's 18, or you can get from our reference table there. So you do what? So the reference table is, you write the way I've explained, guys. So you say argon, it has already, by writing this, it has already gotten what, 18 electrons. So you just bring this one, you say 4s 1 3d what 5. So that is it, guys. So don't forget, you say how to extract what this marks the end of our but the most important thing is you master the way you come up with the electron. So before answering an exam questions with it, write them somewhere. They'll be very easy for you. All right, so I said write them somewhere. So what you do is, you start at p. All right, so you start always at p. Okay, so we know they are in this order, you count them like this, then you start at p. At s you go twice like that. Okay, twice. Again you come like this. Okay, twice. Again you come like this. Twice. Again you come like that. Twice. Okay, so we start with s. You go on p. S. All right, then you come now on DPS. All right, then again you come on what, DPS. Again you repeat DPS. Okay, then you continue like that. Then you come now FDPS. Now you start counting. How many S's do you have? 1 2 3 4 5 6 7 8, like that. Then you come on p. You start at 2. So you start 2p 3p 4p 5p. No, this is 5p, just like that. Then for d also you come, you start at 3. So you start 3d, you go like that. You count all the d's that you start. Your starting point is where it lies number. Okay, going to your right. So that's about it. Thank you very much for watching the video. See you in the next. Make sure that you try to attempt more questions based on this. We have explained everything about electron configuration. Your duty is just to master the format and also write it somewhere before you come across with any question. Then you'll be led to go with any question. All right, concerning electron configuration, except those two guys we have mentioned, they undergo excited state. Thank you very much for watching the video. See you in the next video.